Now, before moving on to talk about examples of neurons of every group, we want to quickly rephrase the notion of linear equivalence in terms of algebraic equivalence. Linear equivalence is just a special case of algebraic equivalence over a certain base. So linear equivalence is stronger than algebraic equivalence. It implies algebraic equivalence. Now, two divisors are defined to be linearly equivalent, or some might say rationally equivalent, if they belong to a rational family. Now, what's a rational family? Well, that's like an algebraic family, but we require that this base is rational. So two divisors are linearly equivalent if and only if they belong to the same algebraic family over a rational base. Emphasis on the rational. Now, how is it related to our usual notion of linear equivalent? Remember, usually we define two divisors to be linear equivalent if they differ by a principal divisor, i.e. the divisor of a rational function. So how is it the same as the notion that we just defined? Well, let's look at the specific case when S is P1. Then we can view these families as fibers of a map to P1, right? Then when D1 and D2 are the fibers over 0 and infinity, we will have that D1 minus D2 is just gonna be the divisor of zeros of f minus the divisor of poles of f, and that's just the divisor of f. So they indeed differ by a principal divisor. One can show that the general case can be reduced to this special case.